There are things that determine the fate of an entire era, yet remain almost invisible to most of humanity. Rare earth elements are one of them. When people speak about resources, they usually think of oil, coal, gold, or natural gas. But in the 21st century, a group of elements rarely mentioned by name is quietly taking a central role in the global competition for technology, military power, and influence. What are rare earth elements that make nations race in silence, even accept rising tensions, just to secure them? This is not a short-term news question. It is a question that sits behind nearly every major technological rivalry in the world today, yet is rarely addressed directly. Recently, international media reported that the United States discovered a large deposit of metals and rare earth elements beneath the Utah desert. The report was not loud. It was not sensational. But to scientists and those closely watching technology trends, it sent a very clear signal, because rare earths have never been just a geological story. They have always been a story of power. Rare earth elements are not soil. They are the collective name for 17 chemical elements, including the lanthanide group, along with scandium and yttrium. Names such as neodymium, dysprosium, terbium, lanthanum, and cerium sound unfamiliar to most people. Yet they appear in nearly every modern technology. What makes rare earths special is not that they are geologically scarce. In fact, some rare earth elements are more abundant in Earth's crust than silver. The real issue lies elsewhere. They are dispersed, not concentrated in large deposits. They are extremely difficult to extract and refine. And most importantly, their extraction leaves severe and long-lasting environmental damage. To obtain a small amount of purified rare earth material, enormous volumes of ore must be processed. Strong chemicals must be used, and toxic waste, sometimes containing radioactive elements, is produced and can persist for decades. This is why many countries, even those with significant reserves, are reluctant to mine rare earths within their own borders. Yet without rare earths, modern technological civilization would slow dramatically. High-performance permanent magnets in electric vehicle motors require rare earths. Wind turbines require rare earths. Semiconductors require rare earths. Satellites, military radar systems, precision guidance technologies all depend on these invisible metals. And most importantly, artificial intelligence depends on them as well. AI is often described as an abstract entity, existing in data and algorithms. But in reality, AI is a massive physical system. Each AI data center consists of thousands of processors, hundreds of servers, cooling systems, electrical infrastructure, and vast quantities of metals extracted from deep within the earth. In other words, AI does not live in the cloud, it lives in the ground. This is why rare earths have become strategic resources of the 21st century. For many years, China has held a central position in the global rare earth supply chain. Beyond possessing large reserves, China controls much of the world's rare earth refining capacity. The United States, Australia, Russia, India, Brazil, Vietnam, and several other countries also hold significant reserves. But having reserves does not equal having power. True power lies in the ability to refine, process, and supply rare earth materials consistently to high-technology industries. When a nation depends on rare earth imports, it is not only economically dependent, it becomes dependent in technology, national defense, and the speed of its future development. This is why many trade and technology tensions in recent years, even when not openly labeled as such, carry the shadow of rare earths behind them. This is competition without warfare. Control the supply, and the balance of power shifts. But Earth is not an infinite resource reservoir. Every rare earth mine leaves behind damaged land for an extremely long time. As technological demand continues to rise, the question is no longer whether we should extract rare earths, but whether Earth can continue to endure it. From this limitation, humanity's gaze begins to turn outward. Within our solar system are millions of asteroids. Many of them are identified as metal-rich. One of the most discussed is asteroid 16 Psyche, located in the asteroid belt between Mars and Jupiter. Studies suggest that 16 Psyche may be the exposed metallic core of an early planetary body, containing vast quantities of iron, nickel, and other valuable metals. NASA launched the Psyche mission not to mine it, but to understand its structure, composition, and the feasibility of accessing extraterrestrial resources in the future. Beyond asteroids, the Moon is also considered a viable target due to its proximity and the presence of valuable elements within its surface regolith. Mars, though far more hostile and distant, also contains abundant metals resources that would be essential if humanity ever establishes a long-term presence there. The idea of mining rare earths beyond Earth may sound like science fiction, but in reality, it reflects a very concrete problem. Technological civilization is approaching the limits of what Earth can sustain. At that point, the discussion is no longer just about science or engineering. It becomes a discussion of ethics, power, and responsibility. Who will control resources beyond Earth? Who will benefit from them? And will moving extraction beyond our planet truly solve the problem, or merely extend an endless race? Rare earth elements, once obscure terms in chemistry textbooks, have become the silent foundation of the modern world. They do not explode. They do not appear in our daily lives. Yet they possess the power to shape technological futures and global power structures. And as humanity continues to dig deeper into the Earth, then reach outward into space in search of metals, the most important question may not be how far we can go, but whether we are wise enough to understand the cost of progress. Follow the channel for the next story.